All right, we're going to finish up this unit by looking at some problems from 16.4, where we're going to sketch the graph of some quadratic equations. It's very similar to what we did last time, where we analyzed some graphs of some quadratic equations, but we're just going to have to do all those steps for ourselves. We're not going to be told what to do here. We are told to make sure that we label the vertex and the intercepts in our graph. So let's start off with the y-intercept here is at 0, 7, which is right there. And I don't have any factors of 7 that add up to be -4. So I'm going to have to try to first complete the square and then go on and use the quadratic formula if I can. Half of -4 is -2, squared is a +4. 7 minus 4 is going to be 3. X minus 2 squared gives me a vertex at 2, 3. So there's my axis of symmetry right there at x equals 2. I know that that means because I was 2 to the left of my axis of symmetry and at 7, 2 to the right of my axis of symmetry will also give me a y value of 7. Because my vertex is above my x-axis and I'm opening up, there's going to be no x-intercepts. I could see that by setting this equal to 0, and I'd get the part that's squared equals a negative number. So there's no x-intercepts here. And I could get some additional points if I would like to, but I'm just going to pretend that we could use the tool to sketch this at this point because we just need the vertex and one additional point, and it would open up like that. Now be careful with this one because it's not written in descending order of exponents. That's really a -x squared plus 0x plus 7. So my y-intercept is at 0, 7. This one's going to open down, and it has x-intercepts are at -√7, 0, +√7, 0, and it includes the y-intercept here when it says all intercepts, so it wants 0, 7. So √7 is between 2 and 3, but it's closer to 3. So it is somewhere in here, and in this region in here, and I'm going to come down like that. My axis of symmetry at y equals, or at x equals 0 right here. And that's it for that problem. Again, it's going to get that much better. Now I would probably choose something, like when y would be -2, then x would be equal to ±3. So I probably would come to points that would be on exactly my coordinates there to help me get my additional points, but I know that the points -3, -2, and +3, -2 are on my graph as well, and I could get some other points if I needed them. Let's go ahead and look for my intercepts here that are at 0, 0, -4, 0, and 0, 0 is already there as an x-intercept, but it's also my y-intercept. So 0, 0, negative 4, 0. That means my axis of symmetry is halfway in between x equals negative 2. It's going to be a negative 4. This is going to open up. The axis of symmetry is always halfway between the intercepts. That's how I found that. There we go. So if we want to use our formula method, negative 4 over 2 times 1 is negative 4 over 2 is negative 2. Plug that negative 2 in to the equation. We get 4 minus 8 is a negative 4. We get a vertex at negative 2, negative 4. Let's go ahead and look at this next one that factors. X plus 1, x plus 3 gives me x-intercepts at negative 1 and negative 3. That puts my axis of symmetry halfway in between there at x equals negative 2 is my axis of symmetry. And that means that I have negative 1, 1 is a negative 1. So this is going to be negative 2, negative 1. And my parabola is going to open like that. It's going to go through y equals 3, 0, 3, negative 1, 0, negative 3, 0. All right, this one gets a little harder because it has a leading coefficient that isn't 1. So let's complete the square here. Half of my middle number squared is going to be 81 over 16. So I just added 81 over 8 and needed to subtract 81 over 8. 2 times x minus 3, 9 quarters squared. And then 81 minus 72 is going to be 9 over 8. So my vertex is at 9 quarters, negative 9 over 8. The x-intercepts are, let's keep going here by setting this equal to 0. You may have never seen anyone do this, but this keeps us from having to complete the quadratic formula. So 9 plus 3 quarters is 12 quarters, which is 3. 9 minus 3 quarters is 6 quarters, which is 3 halves. So, and they want ordered pairs this time. So this is going to be 3 halves, 0, comma, 3, 0. The y-intercept is at 0, 9. And which of these graphs looks correct? This one opens up, and it's going to be stretched by a factor of 2. And I don't have the correct option. There should be A, B, C, and D, and they didn't all print for me. So I'll show you that this one would have a sketch that would go through 2 1/4, and then negative 1 1/8, and it would open up here, 1.5 would open up like this, and through 0.9 up here would be something like that. It's going to grow rather quickly. So you can see that neither of those open up, so they can't be the right answer. It's going to be something like that. But you should get an A, B, C, and D in your MyLabs for this type of a problem that you can choose the correct graph. It's not going to make you graph that particular problem unless it gives you graph paper like this, and then you would have the graphing utility. All right, last problem for this video and last problem for this section. We want to graph negative x squared plus 6x minus 8. So negative x squared minus 6x minus 8 out there. Half of the middle number squared is a plus 9. We just subtracted 9, so we're going to add 9 to balance it out. X minus 3 squared plus 1 gives us a vertex of 3, 1. This one opens down. Let's try and look at its factors if we can. Factors of 8 that add up to be negative 6 are going to be negative 2 and negative 4. So we have intercepts at 2, 0, 4, 0, axis is at 3, 1. Oh my goodness, everything's real close together there. And then negative 8 on my y-axis there. And there we go. There's my sketch, and the intercepts are at 2, 0, 4, 0, and 0, negative 8 are my intercepts. All right. That is it for this section on quadratic equations, and we will come back and talk about another topic in our next unit coming up in our next videos. See you for those videos.